Hey everyone! Welcome back to another exciting episode where we explore the wonders and dangers of our solar system. Ever wondered what would happen if you spent just 5 seconds on Mercury? Well, you're in for a wild ride. Buckle up because today we're diving into the nitty-gritty details of what it's like to visit the smallest planet in our solar system. Mercury may be small, but it packs a punch. First off, let's talk about the environment. Mercury is a planet of extremes, with a landscape that looks like something out of a sci-fi movie. Mercury is a crazy place with extreme temperatures. Imagine the hottest desert on Earth, and then multiply that heat several times over. During the day, it can get as hot as 800 degrees Fahrenheit, while at night, temperatures can plummet to minus 290 degrees Fahrenheit. That's a temperature swing of over 1,000 degrees. That's a range of over 1,000 degrees. Imagine going from a scorching oven to a deep freezer in just a few hours. So right off the bat, you'd be dealing with some pretty intense weather. But that's not all. But Mercury doesn't have much of an atmosphere. This means no air to breathe and no protection from the sun's radiation. This means no air to breathe and no protection from the sun's radiation. The sun's rays would hit you directly, making it feel even hotter. So, if you were to step out onto Mercury, you'd be exposed to the vacuum of space. The lack of atmosphere means you'd be in a constant battle against the elements. You'd be exposed to the vacuum of space. Without a spacesuit, your body would start to lose heat rapidly, and you'd essentially be flash frozen and fried at the same time. Without a spacesuit, your body would start to lose heat rapidly, and you'd essentially be flash frozen and fried at the same time. It's a deadly combination that no human could survive. Now let's imagine you're in a spacesuit. What about the gravity? Mercury's gravity is about 38% that of Earth's. Mercury's gravity is about 38% that of Earth's, so you'd feel lighter than usual, almost like you're on the moon. This lower gravity would make moving around quite an experience, so you'd feel lighter than usual, almost like you're on the moon, but don't get too comfortable. The lack of a thick atmosphere means there's no air resistance, so if you tried to move or jump, you'd go flying further than expected, but don't get too comfortable. The lack of a thick atmosphere means there's no air resistance, so if you tried to move or jump, you'd go flying further than expected. It would be like being in a low-gravity trampoline park. The lack of a thick atmosphere means there's no air resistance, so if you tried to move or jump, you'd go flying further than expected. In those 5 seconds, you'd also notice the sky. In those 5 seconds, you'd also notice the sky. Unlike Earth's blue sky, Mercury's sky is pitch black, even during the day. It's a stark contrast that would be both eerie and fascinating. Unlike Earth's blue sky, Mercury's sky is pitch black even during the day. The sun would appear about 3 times larger than it does on Earth, and the lack of atmosphere means it's just a blindingly bright ball of light. The sun would appear about 3 times larger than it does on Earth, and the lack of atmosphere means it's just a blindingly bright ball of light. It would be an unforgettable sight, but also incredibly dangerous. So, what's the verdict? Spending 5 seconds on Mercury without proper gear would be a quick way to meet your end. Even with a spacesuit, it'd be an incredibly hostile environment. Spending 5 seconds on Mercury without proper gear would be a quick way to meet your end. Even with a spacesuit, it'd be an incredibly hostile environment. The extreme temperatures, lack of atmosphere, and intense solar radiation make it a place where only the toughest robots dare to roam. Even with a spacesuit, it'd be an incredibly hostile environment. Extreme temperatures, no atmosphere, and intense solar radiation make Mercury a place where only the toughest robots dare to roam. Extreme temperatures, no atmosphere, and intense solar radiation make Mercury a place where only the toughest robots dare to roam. But isn't it fascinating to think about? The universe is full of incredible places, each with its own unique challenges and wonders. Mercury is just one of many. The universe is full of incredible places, each with its own unique challenges and wonders. If you enjoyed this journey to Mercury, give this video a thumbs up, and don't forget to subscribe for more out of this world content. Thanks for watching. And don't forget to subscribe for more out of this world content. Thanks for watching. Catch you in the next one. Until then, keep exploring the wonders of the universe. Now that we've survived our hypothetical 5-second visit to Mercury, let's take a closer look at the planet's surface features. Mercury's landscape is a fascinating expanse of craters, much like our moon. These craters were formed by impacts from comets and asteroids over billions of years. The surface is a testament to the violent history of our solar system. One of the most impressive features on Mercury is the Caloris Basin. This colossal crater is about 960 miles in diameter. To put that in perspective, That's roughly the distance from New York City to Chicago. Imagine the unimaginable force of the impact that created such a massive crater. The energy released must have been equivalent to billions of nuclear bombs going off simultaneously. But that's not all. The surface of Mercury also has long, winding cliffs known as lobate scarps. These cliffs were formed as the planet cooled and contracted over time. Some of these scarps are hundreds of miles long and can be over a mile high, making them some of the most dramatic geological features in our solar system. Exploring Mercury's surface, even through images and data from spacecraft like Messenger, provides us with invaluable insights into the planet's history and the dynamic processes that have shaped it. Though it's a hostile environment, Mercury's surface is a treasure trove of scientific wonders. If you enjoyed this deep dive into Mercury's surface, give this video a thumbs up, and don't forget to subscribe for more out-of-this-world content. Thanks for watching. Catch you in the next one. Until then, keep exploring the wonders of the universe. Now let's talk about Mercury's orbit. Mercury has the most eccentric orbit of all the planets in our solar system. This means that its distance from the Sun varies greatly during its orbit. At its closest approach, Mercury is about 29 million miles from the Sun, and at its farthest, it's about 43 million miles away. This eccentric orbit contributes to the extreme temperature variations on the planet. When Mercury is closest to the Sun, or at perihelion, the surface temperature can soar to a scorching 800 degrees Fahrenheit. However, when it's at its farthest point, or aphelion, the temperature can plummet to a bone-chilling minus 330 degrees Fahrenheit. This dramatic range makes Mercury one of the most extreme environments in our solar system. But there's more to Mercury's orbit than just its eccentricity. The planet also has a unique rotational period. Mercury rotates on its axis once every 59 Earth days, but it takes 88 Earth days to complete one orbit around the Sun. This means that a single day on Mercury, from one sunrise to the next, lasts 176 Earth days. Imagine experiencing daylight for nearly 6 months straight, followed by 6 months of darkness. Mercury's orbit and rotation are a fascinating dance of celestial mechanics, providing us with a deeper understanding of the complexities of planetary motion. The interplay between its distance from the Sun and its rotational period creates a world of extremes, both in terms of temperature and time. If you're as intrigued by Mercury's orbit as we are, make sure to hit that like button and subscribe for more cosmic journeys. Thanks for watching. Stay curious and keep exploring the universe with us. While Mercury's eccentric orbit and extreme temperatures are fascinating, there's another aspect of this small planet that captures the imagination of scientists: its magnetic field. Unlike most other rocky planets in our solar system, Mercury has a significant magnetic field. But what's truly intriguing is that Mercury's magnetic field is only about 1% the strength of Earth's. So, why does Mercury have a magnetic field at all? The answer lies deep within the planet. Mercury's core is believed to be partially molten, allowing for the generation of a magnetic field through a process known as the dynamo effect. However, because Mercury's core is smaller and cooler compared to Earth's, the resulting magnetic field is much weaker. Moreover, Mercury's magnetic field is not symmetrical. It's actually offset to the north by about 20% of the planet's radius. This creates a stronger magnetic field in the northern hemisphere and a weaker one in the southern hemisphere. Scientists are still trying to understand why this offset exists, and it remains one of the many mysteries of Mercury. This magnetic field also interacts with the solar wind, creating a magnetosphere around the planet. Despite its weak strength, Mercury's magnetosphere is dynamic and constantly changing, shaped by the intense solar wind it encounters so close to the Sun. Mercury's magnetic field is a reminder that even the smallest planets can hold big surprises. It challenges our understanding of planetary formation and magnetic dynamics, providing yet another reason to keep exploring this enigmatic world. If you enjoyed learning about Mercury's mysterious magnetic field, don't forget to like this video and subscribe to our channel for more fascinating space discoveries. Stay curious and keep exploring the universe with us. Despite its proximity to the Sun, Mercury has water ice at its poles. This ice is found in permanently shadowed craters where the Sun's rays never reach. Scientists believe that this ice was delivered by comets or formed from water vapor outgassed from the planet's interior. Imagine in a world where temperatures can soar up to 800 degrees Fahrenheit during the day, there exist pockets of frozen water, untouched by the Sun's scorching heat. These shadowed craters act like natural freezers, preserving the ice for potentially millions of years. The discovery of water ice on Mercury was made by radar observations from Earth and later confirmed by NASA's Messenger spacecraft. The presence of water ice opens up intriguing possibilities about the planet's history and the processes that have shaped it. Could this ice provide clues about the early solar system? Or perhaps it might even offer insights into the potential for finding water in other unexpected places within our solar system. Mercury's icy poles stand as a testament to the planet's complexity and the many surprises it holds. It's a stark reminder that even in the harshest environments, nature finds a way to preserve its secrets. If you found this revelation about Mercury's icy poles fascinating, please like this video and subscribe to our channel. Let's continue our journey through the cosmos, unraveling the mysteries of our solar system, one discovery at a time. Stay curious and keep exploring with us. Mercury's magnetic field is another fascinating feature of this enigmatic planet. Unlike its neighboring planets Venus and Mars, which lack significant magnetic fields, Mercury stands out with its own magnetic shield, although it is only about 1% as strong as Earth's. This magnetic field is a crucial aspect of Mercury's unique identity. Scientists believe that Mercury's magnetic field is generated by a partially molten core. This molten core, despite the planet's small size and close proximity to the Sun, has managed to sustain a dynamo effect, creating a magnetic field. The presence of this magnetic field suggests that Mercury's core is not only partially molten, but also active, contributing to the planet's dynamic nature. But Mercury's magnetic field isn't uniform. It has anomalies, regions where the magnetic field is significantly stronger or weaker than the surrounding areas. These anomalies could be clues to understanding the planet's geological history and its internal structure. They might reveal past tectonic activity or the impact of massive meteorite collisions. The study of Mercury's magnetic field has been revolutionized by data from NASA's Messenger spacecraft, which orbited the planet from 2011 to 2015. This mission provided unprecedented insights into the complexities of Mercury's magnetism, offering a glimpse into the inner workings of one of the solar system's most mysterious bodies. As we delve deeper into the secrets of Mercury, its magnetic anomalies remind us of the intricate and often hidden forces that shape the planets. These discoveries not only enhance our understanding of Mercury, but also enrich our knowledge of planetary science as a whole. If you enjoyed learning about Mercury's magnetic anomalies, don't forget to like this video and subscribe to our channel. Join us as we continue to explore the wonders of our solar system and beyond. Stay curious and keep exploring with us. Finally, let's discuss the challenges of exploring Mercury. The extreme temperatures and proximity to the Sun make it a difficult target for spacecraft. Mercury's daytime temperatures can soar to 800 degrees Fahrenheit, 427 degrees Celsius, while nighttime temperatures plummet to minus 290 degrees Fahrenheit, minus 180 degrees Celsius. This drastic temperature variation presents unique engineering challenges for any mission. Additionally, Mercury's location within the solar system means that spacecraft must navigate intense solar radiation and gravitational pulls from both the Sun and nearby Venus. These factors require precise planning and robust technology to ensure the success and safety of the mission. Despite these obstacles, NASA's Messenger mission, which orbited Mercury from 2011 to 2015, provided a wealth of information about the planet. Messenger's data has been instrumental in reshaping our understanding of Mercury's composition, geological history, and magnetic field. The upcoming Bepi-Colombo mission, a joint project between the European Space Agency and the Japan Aerospace Exploration Agency, aims to build on Messenger's discoveries. Scheduled to arrive at Mercury in 2025, Bepi-Colombo will deploy 2 orbiters to study the planet's surface and magnetic environment in even greater detail. This mission promises to unlock new secrets and further our knowledge of this enigmatic world. As we continue to push the boundaries of space exploration, the challenges of studying Mercury remind us of the ingenuity and determination required to explore our solar system. If you enjoyed this journey through the mysteries of Mercury, don't forget to like this video and subscribe to our channel. Stay curious and keep exploring with us.